So let's get started with this here now. We see here that in the figure above, not drawn to scale, A, B, C, D. And I want you to notice how I just read a question. I'm not even reading the whole question. I'm just making sense of every word. Right? So A, B, C, D, so that is that shape there, is a parallelogram. Well, I am happy that they tell me that, because automatically, notice I didn't read the rest of the question yet, but automatically I would assume that this is parallel to this, and that this is parallel to this, and therefore they might even be equal vectors. But even if there's not equal vectors, they will be scalar multiples of each other, right? Because they will be parallel, because that's what parallel means. But a parallelogram usually means that this side is equal to this side. And so I could assume that AB is equal to DC, because that's what a parallelogram is. Notice I didn't read the rest of the question yet. I also notice that this vector has an arrow going this way, and this vector has an arrow going this way, which means that this vector here is the resultant of both of them, and that this is a parallelogram law question. Notice I didn't read the rest of the question yet. I just recalling everything I know. Right? I'm making sense of what I know with what the question, right? So ABCD is a parallelogram such that DC is which one? DC, oh, it's 3x. Oh no, we have some x's in here. Oh no. But then again, we just have M and V, and it's all the same anyway. So DC is 3x, all right. And DA is 3y. All right. Thanks for telling me that. The point P is on DB. So I see this is DB. And this is the point P, such that DP and PB is a ratio 1 to 2. That is interesting. DP and PB is a ratio 1 to 2. So does that mean that, and this is not drawn to scale, so does that mean that if this is 1, then PB gonna be 2 of those, 1, 2, right? So really this is also DP and this is also DP. I have 3 DPs inside of here, and this is usually where you guys just make your mistakes. Yeah. So I just making the sense of it have 3 DPs, 1, 2, 3, right? Because DP is the ratio 1 and PB is a ratio 2. So for every 1 DP, I have 2. Well, yeah, you guys get what I say. So express in terms of x and y the vector AB. So AB, wow. Well, AB is equal, the vector AB is equal to the vector DC, because a parallelogram. Therefore, the vector AB is 3x. Right? So the vector AB is 3x. Right? The vector BD. Now this is confusing to me. Do they mean DB? Because DB is the resultant. But no, they don't want DB, they want BD. Right? BD. If I want to drive from B to D and do roadblock, I would have to drive from B to A and A to D. So BD is equal to BA plus A. Right? Notice these two are the same and they could cross off, they could cancel off to give me BD. Right? So BD is equal to, well, I know AB is 3x. So BA gonna be minus 3x plus, I know DA is 3y. So going in the other direction, AD gonna be minus 3y. So therefore BD is negative 3x minus 3y. Or if I want, I could even say 3 into x minus y, but I'm not going to do that. Okay? Negative 3x minus 3y. So Scotia and Shazay, I hope you all okay so far. And if you all have any problems with anything I'm saying, just please stop me, right? DP. So DP is here. That is interesting. I know that BD is going this way, isn't it? And BD is negative 3x minus 3y. That is what BD is. But what about DB going back this way now? Well, going back this way, DB will be the negative of negative 3x minus 3y. So that will work out to be negative 1 multiplied by negative 3 is positive 3x plus 3y. So DB going in this direction is 3x plus 3y. And we already saw here that DP is 1/3 of the entire thing. That is what we was working out. That ratio 1 to 2, that means I have 3 total. 2 and 1 is 3. And DP is 1 out of the 3. Okay? So DP and I know all of this DP, DB, BD thing, this get confusing. So I hope that you guys could follow. Right? DP is actually 1/3 of DB. So DP is 1/3 of the whole thing. So DP is 1/3 of 3x plus 3y. Therefore, DP is simply x plus y. So DP here is x plus y. So Scotia and Shazay, let me hear about you guys. Let me hear about here all this so far. You all understand what I do here?
Yes.
Alright, did you all do this question? You all get this? Alright, so why didn't you get it, Scotia? Part 2 wrong, and is it, well, part 2, is it because of the direction? Right, so you got 3x plus 3y. Right, okay, and that was because of the direction.
So actually, the equation to x plus 1 is 1/3 of 3x plus 3y.
Well, 1/3 of 3x plus 3y, you have to remember you want to simplify your equations as much as possible. Right? So definitely that third could multiply out there. So this is really the best way to have it. Yeah. Now at the end of the day, Scotia, you could be right, but at the same time, because CSEC does really do a set of nonsense by having BD, by asking for BD instead of asking for DB. You know? And next thing you know, they had really meant DB. And CSEC just do that kind of dotishness sometimes. They do, right? So so show that AP, who is AP? AP is this. And you notice the direction from A to P, is equal to x minus 2y. Okay, well, AP is equal to, if I want to drive from A to P, I had to go from A to D and then D to P. So I had to go A to D plus D to P. And you can see the D's cancel off and I have AP there. And once you have that happening, that is the only way that a vector addition could work, right? If you don't have that happening, then you should try to manipulate it where you could get that happening, right? So AD is minus 3y plus DP, we can see, is x plus y. And now we can see that y minus 3y is minus 2y. So we have here x minus 2y, which is the proof. You okay with that, Scotia?
Okay.
Did you get this?
No.
But getting number 2 wrong should not have affected this, right? So why did you get this wrong?
I didn't know what to do.
Oh, but didn't you see here that all I did was a normal triangle law? Because when you are thinking about vector, Scotia, that is what you should be thinking about. You should be thinking about triangle law, parallelogram law. You should be thinking about scalar multiples, equal vectors. All of these things play a role, right? So at the end of the day, they want me to find out what AP is. And all I did was triangle law. AP is AD plus DP. Alright, so watch. I'll do it over, right? They say they want me to prove that AP is x minus 2y. Well, okay. So I'm just going to forget about the x minus 2y. I'm just going to find what AP is. And I'm going to hope that I get x minus 2y. You understand? So AP is that. Alright, let me draw that a little better. Sorry. AP is that. Alright, so AP is equal to, well, the triangle law, if it is that this road not working, I'll have to drive from A to D. You see that, right? Plus D to P, right? Now A to D will be, well, DA, driving in this direction, is 3y. So driving in this direction going to be minus 3y. You understand that?
Yeah.
Plus the DP is, well, we saw here x plus y. And now I could just work it out. Well, y minus 3y is minus 2y. And then I have that x, eh? Right, so now I proved it. I got x minus 2y. So you can see here that in working the question, I didn't have to do anything with this. I just had to find AP and hopefully I got this. You understand? Alright, nice. And don't be disappointed in yourself, eh? Because at the end of the day, I've seen with you, Scotia, that you just be thinking too much. Look how easy this was, right? This was nothing more than a simple triangle law. Nothing more than that. You just had to recognize A to P is a road, right? And it boiled down to the whole road thing again. Yeah? Given that E is the midpoint of DC, all right? So DC is there, so E is the midpoint. So E is here, all right? Prove that A, P, and E are collinear. Oh, this is a tough one. A, P, and E are collinear. Right? Scotia, what does collinear mean? A, P, and E. That they are on the same line. Very good. So how do I show that they're collinear? Shazay, how do I show that they're collinear? I'm only picking on Scotia. Hello, Shazay.
Yes, sir.
Any ideas? Remember, to show that they're collinear, you do it the same way that you just show that they're parallel. And
Find a multiple.
yeah, because if it is, like, let me just say you have AP and PE, right? If you find AP and you could prove that AP is parallel to PE, well, then that is great. You show that they is parallel, right? You show that they are parallel. But guess what? Two parallel lines could never have the same point on them. So the only way that these two could be parallel and have the same point is if they are the same line and therefore collinear. You understand what I just said there, Scotia?
Yeah.
You sure?
Yeah.
Right? So what I have to do to prove that, I have to prove that AP is parallel to PE. Right? And know AP is what? What is AP? X minus 2y. That is what AP is. So I had to find what PE is. Right? PE, going from P to E, that is driving from P to D and then D to E. Would you agree with that, Scotia? Okay. I don't want to use black because black looking like part of the diagram. Okay. So PE is driving from P to D plus D to E. So PE is P to D. Well, I know D to P is X plus Y. So P to D going to be minus X plus Y. Right? Because of the direction. DP is X plus Y. You have that here. So going back in the other direction, PD, sorry, not P to E, sorry. Oh yeah, it is P to E over there. PE is equal to PD is minus X plus Y plus D to E. Well, where's D to E? Well, we know D to C is 3X. And we know that E is in the middle, in the midpoint. So therefore, D to E going to be a half of the entire thing, a half 3X. So you're okay with this so far, Scotia? You sure?
Yeah.
Alright, nice. So PE now is, well, minus in front of this X plus Y going to give me minus X minus Y plus a half multiplied by 3 is 3 on 2X. Right? So therefore PE is equal to, well, 3 on 2 is 1.5, and yeah, so 3 on 2x minus x. 3 on 2 minus 1, that is leave me with a half x. A half x. And then I have minus y. So therefore, AP is equal to x minus 2y. PE is equal to a half x minus y. So we could see here that they do look like scalar multiples of each other, right? if I take PE and multiply it by 2, I will get AP. PE multiplied by 2 will give me AP. So AP is 2 multiplied by PE. And these 2 cancel here, and 2 by y, and I'll get x minus 2y. Right? So, just to recap, they want us to show that AP and E are collinear. Well, in order for AP and E to be collinear, I could take AP and show that it is parallel to PE. And because they both share a point, means that they'll have to be collinear. I know AP is this, but I just had to find PE. PE, I just used basic triangle law, and you will find that most of your vectors questions, you'll just have to use a triangle law or a parallelogram law. So PE is PD plus DE. PE is minus x plus y plus a half of 3x. When I do the algebra, that is boiled down to PE being a half x minus y. So we could see here that this is where I start to compare them. I'll say, well, are they scalar multiples of each other? Well, yes. If I just take PE and multiply it by 2, I will get AP. Right? Therefore, AP is equal to 2 PE scalar multiples therefore collinear. So how do you feel about this one, Scotia?
Okay.
Okay. Any questions? Anything you don't understand? OM and ON are position vectors with respect to the origin, right? Such that OM is small m and ON is small n, right? Now, L is the point on MN. All right, so I guess in here, let me just draw a sketch, and I don't know how this is going to be, right? But you know, I'll just draw a sketch just to see. Let's just call this OM, and this is O. Let's just call this ON, right? And OM, we calling that small m. ON, we calling that small n. Right? And they say in here that MN, I have this vector MN. Right? So L is a point on MN such that ML to LN is 2 to 1. So L, ML, so L will be somewhere here. Right? So that means that this is 2 and this is 1. This is 2 to 1. Right? So that means that this MN, and remember, I didn't really read the whole question yet. MN is really 3 times LN. Right? And I hope that you guys, so Scotia should say, you all understand how I came up with that, right? 3LN. Right?
I can use.
Right, so it's a ratio right here, right? So you know how you just work ratios, right? So ML is the 2 and LN is the 1. So 1 plus 2 is 3. You have a total of 3 parts in the ratio. And out of those 3 parts, LN is 1 out of the 3 parts. And ML is 2 out of the 3 parts, right? So you can see here that LN is 1 part and ML will be 2 parts. So therefore, you know, this is a 1 to 2 ratio. So one of this, right, will give me 2 of these. So ln, and then so here is L to n, and then here is ln as well, and then here is ln as well, to give me the 3 parts, right? So because of that, I could say that mn is 3 ln. How does that do for you? Alright, so draw a sketch of that and label black. Okay, I just did that. So you see how important the sketch is? Yeah, you could even get marks for it, right? Write in terms of m and n an expression for... Now let me tell you, a question like this is more of a question that you would probably get in your exam, right? Not a question like this. This is real 2008 kind of thing, right? But a question like this is more of the kind of question that you would get, especially in a pandemic, right? Write in terms of m and n the expression for mn. Well, mn triangle law. Mn is really if I drive from M to O, and then I drive from O to N. You see the O's cancel off there, right? M to O, well, OM is small m. So M to O will be minus small m, right? Plus ON, which is N. So therefore, and you should use your commutative law to put it N minus M is the answer here. Well, yeah, I mean, this is good manners. Yeah, this shows that you know what you're doing in maths, right? When you put it in that order, you use your commutative law, and you put it in an order with the positive minus. So you put it in a subtraction, right? Because it's kind of like doing a question where you have minus 3 plus 4, but you could flip it into just 4 minus 3, and this is obviously the easier one to deal with, right? So, but yeah, you got it correct, right? And what did you do wrong there, Skusha? ML, so ML. Well, any ideas for ML? How could we do ML? We already know what MN is. MN is N minus M. So this entire thing is N minus M. So how do I get ML? Yes, ML, right? ML is 2/3 of the entire Mn. So therefore ML is 2/3 of N minus M, and you could leave it like this, no problem. 2/3 of N minus M plus OL. Right, so but remember you had OM plus OL, but it have nothing to cancel off here. This cannot be added, right? It have to be MO plus OL, so that these two could cancel to give you ML. You understand, Scotia?
Yeah.
And this is the exact same mistake that you made last class, right? Where it has to be in a certain way, right? Not only that, but we don't know OL, right? We never found what OL is. And at the end of the day, you kind of had to look at what you have. We have MN, and we know that ML is some fraction of MN. But what fraction? Well, look, we have that. And that will tell us that, well, all right, this is 1/3. So that means that this will be 2/3. You understand, Scotia? Now we say if M is that and N is that, determine the position vector of L. So the position vector of L is OL, right? If small m is that and that is that, right? So the position vector OL is equal to OM plus ML, right? So OL, that's not, let me see if I do that, is equal to OM plus ML. And you can see there that those M's could cancel off and I'll just have, right? So OM is, where's OM? OM is just M plus ML, which we worked out here to be 2/3 into N minus M. Okay. So now we just add in our vectors now. So we have M being the vector 3, 6 plus 2/3 of N, which is 9, 0 minus M, which is 3, 6. So we can see here that this is 3, 6 plus 2/3 into multiplied by, and this 2/3 here, I wouldn't put it in brackets because it's not a vector, it's actually a fraction, right? 2/3 multiplied by, well, 9 minus 3 is 6, and 0 minus 6 is negative 6, right? So now we have here 3, 6 plus, when you're multiplying a scalar quantity by a vector, you multiply by the x value and the y value separately. So this is 2/3 by 6. Well, that'll cross into that. 2 3s are 6, 2 2s are 4. So the x value there will be 4 and the y value there will be negative 4. Remember, if I have a vector 1, 1 and I'm multiplying, and this is when we did vectors multiply by a scalar, right? You just take the 2 and multiply it by the x, and then you take the 2 and you multiply it by the y, and remember that?
Yeah.
Right. So that's all I did there. I took 2/3 and I multiplied by 6 and the answer was 4. And I took 2/3 and multiplied by negative 6 and the y answer is negative 4. You okay?
Yeah.
You sure? 2/3 times 6, 3 into 3 is 2, 2 2s are 4, right? 3 into 6, right? So you're sure you're okay, so it's not kinda anymore, right? Alright, cool. And now we just add, we think, so 3, add the x's, so 3 and 4 is 7, and we add the y, 6 plus minus 4 is 2. And so that there is the position vector of L. So therefore, OL is equal to 7. So I'll just cut them down real quick so that we can go early. And Scotia, I would remind you to try to go and look at those vectors videos, and especially look over all of the vectors questions that we did, right? Because I find that you have been grossly overthinking this topic, and this topic is a lot easier than you are making it to be, right? So the diagram below, not drawn to scale, P and Q are the midpoints of OA and OB, alright? So P and Q are the midpoints of OA and AB. Okay, that's good. OA is written as the vector 2A. So OA is 2A, right? And OB is written as the vector 2B. So OB is on this side. This is 2B. This is 2A. This is 2B, right? OB. So OA, remember OA is going in this direction, and OB is going in this direction. Expressed in terms of A and B, the vectors AB. AB. And I don't like how they just go direction here, right? But the vector AB if I want to drive from A to B and the road block, I'll need to drive from A to O plus O to B. Right? So A to O is negative 2A because OA is 2A, so AO is negative 2A plus OB, which is 2B. So therefore the answer is 2B minus 2A. Right? So AB is 2B minus 2A. PQ. So I want this vector here, P to Q. And I have a feeling that they're going to ask me about PQ and OB being parallel. I have a feeling. Look, they asked it here, you see? Stupid CSEC people. Right? So, P to Q, I want a vector P to Q. Well, P to Q, I could say, I mean, I could go all of the way around here, right? But that is not triangle law, because that's more than a triangle. Look, I have a triangle here. So maybe I could say that P to Q is equal to P to A plus A to Q. P to A plus A to Q. And notice with all of these things, these two are the same. These two are the same. And the outside is actually what you want to get. The outside is what you want to get. PA, well, we can see this whole thing is 2A, and we know that P is the midpoint. So PA will be a half of that 2A. And I'm leaving the 2A as a positive because PA is going in the same direction as the 2A. So it will be positive. But we saw that AB is 2B minus 2A. So therefore AQ, we know that Q is the midpoint. So that'll be a half of 2B minus 2A. You're okay so far, Scotia?
Yeah.
Alright. So at the end of the day, these twos will cancel. I'll just be left with A plus, well, this half will cancel with the 2, so I'll be left with B minus. This half will cancel with the 2, so I'll be left with A. So therefore, A minus A, PQ is actually just simply B. Right? State two geometrical relationships that exist between OP and OQ. Well, I know that all you're going to ask about that parallel thing. Well, we see here OB, and this one really easy, 2 marks. OB is really 2B, and we see here that PQ, which is what we just found, is just B. Yeah. So therefore, OB is if you take 2 and multiply it by PQ. Right? Hence, two geometrical relationships. So the first one, and please learn these two by heart because we've done like 4 questions that ask the same exact question. The first one, the first geometrical relationship is that they are scalar multiples. And then the second geometric relationship is that they are parallel. Scalar multiples, parallel. Right? Shazay and Scotia, the two earlier hammer vex because the two earlier am making all your statements. You can see how I just do a question. Oh gosh, every time we in class, I just only do a question one way. While I don't take the example. Look, I'm gonna do this question the same way. I'm gonna do it piece by piece, and I'm going to make my statements. Right? So given the vectors OP, well, I see here O, that seems like a position vector. PQ and RS, okay, determine the vector OQ, alright. I mean, let me try to draw a diagram. I could try to draw a diagram, and P gonna be 1, 2, 3, and then 1, 2, 3, 4. So that is P, which is the point 3, 4, and so therefore OP is the vector 3, 4. Right? I could see here that P to Q, to move from P to Q, I have to move -1, so that is one space here. No, one space this side, sorry. -1 is one space this side, so I'm gonna be by 2, and then 2 spaces up, 1, 2. So I'm gonna be here. This is 2, 4, 5, 6, 2, 6, right? So let's just see. Right? So I could say that, you know what? Determine the vector OQ. OQ. Let me just see. And I'm doing this in scrap first before I make my statements, right? I could say OQ is OP plus PQ. Yeah? Right? So you can see here OQ. I could do it like that. It have other ways that I could do it. There are 3 different ways that I could do this question. OQ is OP plus PQ. You see, first thing I do is I make my statement. I make sure these 2 things are correct. These 2 things are the same, and these 2 outsides supposed to give you this. Right? I don't know how much times I just had to tell all of them things. Right? So OQ is OP plus PQ. Right? And I could see it here. Look at my sketch. And I say look at my sketch and I rub it off. Right? 1, 2, 3, and then 1, 2, 3, 4. So that is the point P. OP, right? And then PQ, from the point P to Q is -1, and then going up 2, 1, 2. So that here is the point Q. Right? And I worked out, just by using that -1, 1, 2, I worked out that the point Q is, if P is 3, 4, you go -1, so the point Q is going to be 2, and then you go up 2, so that's 2, 6. Right? And I just worked that out, and that graph thing is not the vector, method. Eh? So when they ask you to do the vector method, don't do that. Right? But you could use this graph thing to find out the answer, just in case. Right? So OQ is OP 3, 4 plus PQ. So OQ, which is here, triangle law again, is OP plus PQ. Right? So plus PQ, which is -1, 2. So 3 minus 1 is 2, and 4 plus 2 is 6. So you see, I use this graphical method, which is not the vector method, but because I know my work so well, I use the graphical method, and I found the point Q way before. Yeah, and now I use the vector method, where I use triangle law or parallelogram law or one of those things to get the point 2, 6. Shazay is kosher. All you make mistakes with this one too? How will you do with this one? Alright, good. You get away from your buffet. Nice, right? Show that OQ is parallel to RS. I have no idea what RS is, but I know RS is 1, 3. I know that. It's not a position vector though. Only because OP is a position vector meant that I could have found the point P. But RS is not a position vector, so that them points could be anywhere. I don't know what R is, where R is, and where S is. Right? But RS is that, and they want it parallel to OQ. OQ is 2, 6. Well, oh gosh, you could see that these are scalar multiples, right? So therefore, OQ is equal to 2 multiplied by RS. right? They're therefore parallel. This is the reason. Give a reason for your answer. That is the reason, right? When they are scalar multiples of each other, right? You see that is just one mark. Ooh, look like this. This is a different question here now. It's part of the same question, but it's a different question. And this question here, this question is kind of pretty much the kind of question that all you're going to get for all your exam next month. This is the kind of question you're going to get. You're not going to get the hard question like what we started off this class with, right? You'll get a question like this. X, Y, Z is a triangle and M is the midpoint of XZ. So I don't know how this triangle is, but X, let me just draw a triangle. We call this X, Y, and Z, right? And M is the midpoint of XZ, so here have a midpoint M. Alright, XY is the vector A, XY is the vector small a, and YZ is the vector small b. Alright. Express the following in terms of A and B, simplifying your answers where possible, Shazay. Yes. XZ. Well, XZ, easy thing, one mark. XZ is simply XY plus YZ. This statement that you make is half of the mark. If you had just written the answer alone, you would only get half mark, right? This statement here is half the mark. XY plus YZ, that is XZ. So XY is A and YZ is B, therefore XZ is equal to A plus B. Do not make the mistake of seeing one mark and thinking, oh, okay, well, I could just put the answer, alright. No. Forget about how much marks it is and you make your statements, right? Look at this. This is a story and anybody will read this and fully understand what I did. Fully. Especially if I have a diagram in the corner, right? And you can feel free to draw a diagram on the question sheet and the answer sheet, no problem. Right? In fact, I recommend that all of your working and diagrams and scrap diagrams and things, you hand up all of those. You do those right on the question sheet or on the answer sheet, no problem. Right? MY. Who is Y? They give you a Y? Oh, YZ. Oh, yes. Okay. Alright, yes. So I want M to Y. M to Y, I could take that as, I could take it in two ways. I could take it as MX plus XY. So MY, and I'll do it the two ways and we'll see if we get anything different. MY is MX plus XY, or I could say MY is equal to MZ plus ZY. So I could go this way, MZ plus ZY. Let's see if we'll get the same answer for both of them. Now I know that this M is the midpoint, so it'll be half of whatever XZ is. But please be reminded, XZ is going in this direction. Right? So therefore XZ in that direction is A plus B. Right? So if I go in MX, I can't just say a half A plus B. I cannot do that. Yes, right? You'll see why. MY is equal to MX are going in the opposite direction. So yes, it is a half A plus B. Yes, it is. But I have to put that minus sign there because I'm going in the other direction. So minus a half of A plus B, that is MX, plus XY, which is just simply A. So that gives me negative a half A minus a half B plus A, which gives me the answer here. A minus a half A is just simply a half A minus a half B, right? Or in this one here, let's try this one. MZ, this is the half A plus B, right? And you notice MZ going in this direction now, and that goes with the direction of XZ. So I don't have to put no negative there. I'm going with that direction. Plus XY. Well, remember ZY. YZ is positive B, yeah? YZ is positive B. So ZY is going to be negative B. So now I have a half A plus a half B minus B, which gives me a half A minus a half B. So you see, either way that you went, you would have gotten the same answer, right? How many questions we have again to do? This last one? Well, let me just do this last one real quick. The diagram below shows the position vectors OP and OQ. Thank you. OP, and I can see in here the point P is 3, 2. And I can see here the point Q is negative 1, 3. I could see those things plainly. Write as a column vector in the form XY OP. Well, oh gosh, I just did it, right? OP is the 0.32, right? The P is the 0.32, so therefore OP will be 32. And Q is the point negative 1, 3. So that means that negative 1, 3 is going to be the position vector, right? So I read that right off the graph, nice and easy, 1 mark each, right? The point R has coordinates 8, 9. Wow, well that's way off the graph. Express QR as a vector of the form. All right, the point R, QR. So from Q, I want to go to R. But R is off my grid. And I don't know what the point R is. Oh no, they tell me the point R here, 8, 9. So the point R is 8, 9. Yeah? And I know the point Q is 1, 3. So I could use vectors as a translation for this. So the point Q plus the vector QR will give me the point R. Right? The point Q is negative 1, 3 plus the vector QR, which is XY, will give me the point R, 8, 9. So you can see here, if I throw across the negative 1, right? Therefore, X is what? If I throw across the negative 1, it will be 8 plus 1, which is 9. And if I throw across the 3, it'll be 9 minus 3, which is 6, 7, 8, 9. So Y there is 9, 6. So therefore, the vector QR, therefore QR is equal to 9, 6. Yeah? So that's one way. Right. Using a vector method show, or just let me just write this as 9, 6 because I might need that. Right. I don't know. Did I get that wrong? Anybody have a problem with that? I'm not sure if I may have made a mistake or not. I didn't eat any food today, so I'm super hungry, which is probably why I vex. You see, all again, my vex on the day that I'm hungry, dread. All you must know better than that, right? All you must know better not to get me vexed when I'm hungry. Okay? Using a vector method, show that OP is parallel to OQ, the QR. Okay? OP is what? OP is 3, 2. QR is 9, 6. So I could see here, therefore, QR is equal to 3 multiplied by OP. Right? Therefore, parallel. That's all you had to put. Right? All you had to put. You state them, you show the scalar relationship, show that they're parallel, you get your 1 mark. So yes, they are parallel, right? Using the vector method, all right, determine the magnitude of PR. Where's PR? From P is here, and R is here. So the magnitude of the vector PR, that's interesting, right? Because the point P is 3, 2. The point R is 8, 9. So therefore the vector PR is the vector that will take P plus the vector PR, and that will give me R. So I had to find the vector PR first. So the point P is 3, 2 plus the vector PR xy is equal to 8, 9. That is the point R. Right? So therefore, xy is going to be equal to 8 minus 3 is 5, and 9 minus 2 is 7. So therefore, PR is equal to 5, 7. Right? So hence, the modulus of PR is going to be the square root of 5 squared plus 7 squared. The magnitude or modulus of PR, right? Or magnitude. So 5 5s are 25 plus 7 7s are 49. 25 plus 49 is 74, the square root of 74. You can actually leave your answer like this if the square root of 74 works out to be some stupid thing. Yeah, the square root of 74 works out to be 8.602, but it goes on forever. So you could actually leave your answer like this, or I mean, this is preferred, really and truly, but this is more exact. Yeah. So, question? Okay, all right. Yes, that's the only time that you'll actually be participating in classes by accident. Huh? Yes. All right. Oh God, all y'all hungry and I want to go, and the question just don't want to end. And it's 5 o'clock and it's past our time, but this is the last question though, so let me just cut it through. Let's just cut it through, right? The point S has coordinates AB. Okay. What did I get for PR? PR, the vector PR is 5, 7. So let me just put that over here. 5, 7. PR is 5, 7, just in case I need that, right? The point S has coordinates AB, okay? Write QS as a column vector in terms of A and B. What? Where Q is? Did it have Q in this question? Alright, look, Q is over here. Q is over here. And they're saying that the point S has coordinates A, B. Those are the coordinates. Right? So therefore OS, right, is going to be A, B. Right? That is OS, is A, B, right? Write QS as a column vector. Well, what do I have? I have write QS as a column vector in terms of A and B. QS QS, I don't know where S is. Right, QS as a column vector of A and B. So I could say QS as a column vector is OQ it's QO. I found it. QS, right, is really QO plus OS. So QS is QO plus OS. I know QO, well OQ, I know OQ to be this, -1, 3. So QO gonna be minus that, minus -1, 3. Plus OS, which is AB. So therefore, right, this is multiplied by a scalar, so this will actually be +1, -3 plus AB as a column vector in terms of A and B. So you're expecting a column vector here. So the X value is 1 plus A and the Y value is B minus 3. So this here is your QS, which is a column vector in terms of A and B. And this is A, this is not 9, right? Now you see here, I didn't know, and it was tough for me. I mean, it made me pause for a minute, right? It made me pause for a minute because, all right, they say the point S is AB. Well, that means I can't draw S on my sketch because I don't know it's AB. I don't know what the point S is, right? And write QS as a column vector. All right, QS. Well, I see that QS have the point Q in it. So the point Q gonna have to play a role somehow. I don't know where is QS and I don't know where is the point S. But the point S, if there's one thing I do know, is if this is the point S, then I could take that and write that as a position vector OS. Because all of the points, you could write points as position vectors. So that means that I have OS, and look, I have OQ. So, and that is when it dawned on me. Well, okay, let me use the triangle law here, and you can see that I make sure that my O's could cancel there, and I make sure that the outside I had the Q and the S, and things worked out from there. So yes, this one did give me a little bit of pause. But at the end of the day, what did I do? I looked at what I had. I had this. I looked at the clues. This Q was a big clue. The Q was a clue, right? So let's finish off so that we could go home because Soraya getting grumpy now. QS. I have QS as 1 plus A and then B minus 3. That's what I got QS to be. Now, they say QS is equal to OP, calculate the value of A and B. Oh God, this is easy. 3 marks for this, 2 marks for the next one. OP is 3, 2. So OP is 3, 2. So therefore, if QS is equal to OP, that means that the X values are equal. Therefore, 1 plus A will be equal to 3. Right? 1 plus A is the X value for QS, and 3 is the X value for OP. And then B minus 3 is going to be equal to 2. These are the Y values. Right? So therefore, we can see A is, you fling across the 1, 3 minus 1 is 2. And then B, you fling across the negative 3, so 2 plus 3 is 5. So A is 2, 3 is 5. Now you could see that even though we have weird stuff like this, 1 plus A, equations inside a column vector, even though we have weird looking things, right? All I really have been doing was using my triangle law. I just using those very simple things that we found. And you can see that everything that I did for all of the questions was just using those simple things from the cheat sheet, right? Using the vector method, show that OPSQ is a parallelogram. Okay, well, since I know A is 2 and B is 5, therefore the point S is 2, 5. So now I can kind of draw it here and see what's going on. The point S is 1, 2, 1, 2, 3, 4, 5. So the point S might probably be about here, right? And then I know the point R is 8, 9. So 8 is all the way down here, and 9. Oh no, but they didn't have R here. They have OPSQ. So OPSQ is a parallelogram. 3 marks for that, right? So to show OPSQ is a parallelogram, I need to show, well, I could show that the opposite sides are parallel, yes. But because it's a parallelogram means that those opposite sides are actually going to be equal vectors, right? So therefore I need to show that OQ is equal to PS, and I need to show that OP, which is this one, is equal to QS, which is that one. So let's get it going here. OQ, I know that OQ is negative 1, 3, and I just write down all the information here. I know that OP is 3, 2. I know that OS is equal to 2, 5, right? Yeah. And I know that OO is 0, 0, right? So OQ is equal to PS. So therefore PS is equal to, what is PS? PS is PO plus OS. So PS is PO, which is negative 3, 2, because OP is 3, 2, plus OS, which is 2, 5. Therefore that is 2 minus 3 is minus 1, and 5 minus 2 is 3. Right? So now we see in here that PS is equal to OQ. Therefore, parallel. Right? And that is one part that we proved there. So that is 1.5 marks we get for that. And the other part we had to prove is that OP is parallel to QS. Do I have QS? Did I ever work out QS? Given QS is equal to OP. Oh yeah, well look, I have QS here. Remember QS was equal to what? 1 plus A into B minus 3. So that is, we saw that A is 2. So that is 1 plus 2 is 3. And then B is 5, so 5 minus 3 is 2. And now we can see here that QS is equal to OP. right? So because look, OP here is 3 on 2, and QS we found that to be 3 on 2. So because we found that OP is equal to QS, we also found that OQ is equal to PS, right? OPS is equal to OQ and QS is equal to OP. Therefore, there's a parallelogram. Both pairs are parallel and they are a parallelogram, right? And in terms of statements, you're supposed to make those statements therefore parallel, right? Hence P, Q, S, O, or P, O. Wait, how do they put it? OPSQ. OPSQ is a parallelogram. Nice.